Good morning, everyone. I'm Brad. I'm a Principal Security and Compliance Specialist with Amazon Web Services Public Sector team, so I work globally with our public sector customers on issues that deal with security and compliance.
Hi, everyone. My name is Rohit Aswani, and I'm a Senior Networking Solutions Architect within Public Sector, and I work with all of our public sector customers on their networking designs.
Great. So today we wanted to put together a talk that started to talk about three areas that we see come up a lot in the US federal space: Zero Trust, TIC, and IPv6. And what we saw working with customers is that there's a pretty significant amount of overlap between different compliance frameworks, the OMB mandate for IPv6, where these all overlap. So we wanted to try to help customers better understand where these overlap through the lens of a couple different architectures, and to understand what capabilities exist today to speak to each one of these and how we can do it. Before we dive into the sort of the architectures and the technical bits, we wanted to kind of level set and explain some of the foundations of what these different areas are in case you weren't familiar. So TIC, or Trusted Internet Connection, comes from CISA, and we are on the third iteration of TIC. The way that you evaluate TIC is through the lens of the NIST CSF. And so when we look at individual TIC policy enforcement points, or PEPs, we use the CSF to help us interpret and understand the individual PEPs and controls. TIC3 basically is an iteration from the previous version of TIC, and then the thing that you need to know here really is TIC3 moves to an outcome-based model. The previous versions of TIC were really much more focused on specific tools and technologies. TIC3 is much more agnostic. It doesn't really care about what solution you use so much as the outcome that is used for the solution. So what do you need to know from a TIC perspective? Again, TIC3 moved to an outcome-based model. There is no single solution for TIC. It's based on use cases, overlays, or alignment to the PEPs. This is one of those areas that we see customers get confused on today, is that there's this assumption of, I need the TIC solution. There's no such thing. TIC is going to be an amalgamation of a few of these different technologies. Nobody gets a sticker from CISA for TIC. So this is another area where folks get confused. You know, how do I get my badge for TIC compliance? You don't. This comes from your agency's risk management team. They're the one that's going to audit your artifacts and give you the ability to say that you are or are not in compliance with the TIC requirements. TIC is more than just networking. So everybody focuses on the I in TIC, but really there's a lot more in the individual TIC's policy enforcement points. Things like logging, monitoring, patch management. So it's important to focus not just on patch, or not just on the networking component, but also holistically the PEPs that are in the TIC framework. And today, if you were to go read the security workbook for TIC, it still uses the word trust boundaries. CISA has been pretty clear that over time that will likely migrate to zero trust. As you can imagine, that has something to do with this talk. So we want to set customers up for success from the beginning. So we've always been telling customers since TIC3 went into non-draft status that we really want customers to embrace a zero trust model and really not focus on the current design, which is trust boundaries. We don't think it's the right way to go. From capability that AWS has today in terms of what we offer customers, we're going to be publishing a mapping artifact that walks through each of the different policy enforcement points, PEPs, mapping to the NIST CSF, and then we also did a crosswalk to 853, R4, and R5. Today we've been sharing that one-on-one with government customers. It's something that we're going to publish outwardly a little bit later on. We've supported a number of US federal customers on their pilots, and we've been able to move those pilots into production successfully. So if that's something that you're working on right now, we'd love to talk to you and help share those lessons learned. We work really closely with the partner and vendor community. Again, as I said, there is no singular solution for TIC, so we want to work with those partners to help you meet the different requirements that you may be embracing existing technologies or partner solutions. We want to help incorporate that into your TIC solution. And we're going to be publishing our overlays shortly on some of the published use cases as well.
So what is IPv6? So as you all already know, IPv6 stands for Internet Protocol version 6, and in the industry has been trying to adopt and moving towards the IPv6 solution. That's partly due to one of the major driving factors being the exhaustion of the IPv4 address space. And also there are some government mandates such as OMB mandate where customers as well as the US federal agencies are moving towards IPv6 architectures. So OMB released a mandate in November 2022 where they mandate the US federal agencies to have 80% of their IPv6 enabled assets by 2025. And we have been working with multiple of those customers to help enable that part. So AWS is committed to enabling IPv6 for our customers to help meet the OMB mandate for our customers. So in terms of what do you need to know today, we have supported IPv6 for a very long time. So if you go back a couple of years ago, we have had support for IPv6 in Amazon VPC, where it supports IPv6 in a dual stack mode. Recently, a few months ago, we launched a capability called IPv6 only subnets that can coexist within the same dual stack VPC, and you can launch IPv6 only EC2 instances within that IPv6 only subnets. In addition to that, we have had support for IPv6 for various of our AWS service endpoints such as S3, and in the last couple of weeks itself, we have added support for more services like AppMesh, Lambda, and other services. In addition to that, if you look at it from a VPC to VPC connectivity, I'm assuming that a lot of customers here are running workloads within multiple VPCs, so you can have connectivity between the two VPCs over IPv6 today using either using VPC peering or transit gateway and scale those workloads to hundreds and thousands of VPCs over IPv6. You can also extend that same connectivity back to your on-premises environment and connect to those environments using IPv6, and you can use AWS Direct Connect or site-to-site VPN connection to do that. If you're also having internet-facing applications that are front-ended by either a load balancer, such as application load balancer or network load balancer, we have end-to-end IPv6 support for ALB as well as NLB. Last but not the least here, we also enabled IPv6 support for local instance services such as instance metadata service, Amazon timesync service, and VPC DNS server there. So what does this look like from the current state of for IPv6 on AWS? So here's the number of services that we have today. And in addition to this, as you can see in the last column here, some of these services we have just launched in the last couple of weeks. That includes, for example, like Amazon RDS and multiple IPv6 header blocks and private link support, which a lot of customers have been asking us about. And here are some of the resources that you can take a look at it. We have published a blog showing our commitment to US government for moving them to IPv6 for the OMB mandate. In addition to that, we have also published white papers, blogs, and reference architectures, and we are working with multiple customers in a one-on-one setting to think about their IPv6 addressing strategy, as well as the adoption and the migration patterns.
So the last thing that we're going to touch on is Zero Trust. So when I sit down with federal customers and talk about Zero Trust, the first question that we have to answer is which? So which Zero Trust are we referring to? So there's the NIST version of Zero Trust, 800.207. There's the CISA version of Zero Trust, which sort of relies on 800.207. There's the DoD version of Zero Trust. And then there's vendor versions of Zero Trust, right? So what we tried to do in this talk is sort of blend between all of them. But I think it's important to know what is Amazon's version of Zero Trust. So first, when we talk about Zero Trust with customers, the thing that we want them to understand is that it's not about making a binary decision. And what we mean by that is oftentimes customers are focused on, well, it's an identity problem or it's a network problem. It is neither. It's an and statement. You have to evaluate Zero Trust through the lens of both network-centric controls as well as identity-centric controls. The best example of that is how you communicate with AWS IP or API endpoints. It is both a network control as well as an identity control, and this is something that we use through our SIG-v4 signing algorithm. The next is focusing on use cases. So it's important to focus on the actual use case that you're trying to solve, and when you create your Zero Trust boundaries, make sure that you're evaluating it through the lens of the data classification and the type of workload that you're actually protecting. It's very different to evaluate the risk of, say, a cafeteria menu system that is hosted on a completely separate account versus something that's alongside a sensitive bit of federal information or regulated data set. It's also really important that you don't try to shoehorn technologies into a one-size-fits-all model. What we see oftentimes is that customers have a set of tools that they're told that they need to use, and what we really want to encourage customers to do is not force a one-size-fits-all model. Oftentimes when customers go through tabletop exercises to develop their zero trust strategy, the output is something like, well, we want to assume that all resources are compromised, and we want to assume that all compute resources have to be hardened to the absolute standards, so we're going to enable SE Linux across the board, and a bunch of other things that are not necessarily required for that type of workload. So don't put inflexible mandates into your environment. You should be addressing risk when you develop your strategy, and you should be addressing the individual requirements that are most applicable to your agency and to the risk of the workload. So there's a number of blogs that we've published, as well as reInvent talks and other summit talks that talk about how AWS views zero trust, but these are all resources that we would advise you take a look at and help you better understand how AWS feels about zero trust and how we talk about it with our customers. So that's the level set. We just wanted to get everybody on the same page. So oftentimes what we found in talking to customers is that there's actually a pretty significant amount of overlap between these three. And so what we wanted to do was showcase a few different architectural patterns and help you understand where those overlaps are, and also what today is possible natively, what today requires third-party solutions, and what has and hasn't worked. And so to kick us off, one thing I wanted to call out from the get-go is that these examples are not meant to be completely comprehensive. We had to develop something that was able to sort of showcase a couple different scenarios. So it's important to note that, again, it's not a comprehensive solution. The other thing is that because the session is being recorded, for those that are watching this later on in YouTube, we also want to stress that this is based on a point in time. We really wanted to show today this audience what you can and what may be a struggle to do, but in 6 months from now, some of these issues may be addressed. So the first scenario that we wanted to walk through is a simple 3-tier architecture where we're communicating with a remote application hosted into a separate VPC or a separate account. And so you can see we've got a traditional flow going through Route 53 to a fleet of web servers that are backed behind a load balancer. What we've tried to do for each one of these is annotate where there is an IPv6 component, where there's a zero trust component, and where there is a TIC component. And what we want to do is walk you through a couple examples in each one of these scenarios to help you understand how to interpret these architectures and how to understand how to apply those principles. So, for example, on the first area that we wanted to walk through is the web application firewall in this design, or WAF. So from a TIC perspective, this allows us to speak to, for example, the WebPEP controls. So this allows us to perform DDoS filtering and content filtering, as well as bandwidth control. And that allows us to do things like rate limiting on the web application firewall. Upstream, we have the AWS Shield or Shield Advanced service. Oftentimes, if we're using Shield Advanced, one of the capabilities that leverages some of the more advanced DDoS capabilities is WAF behind the scenes. And so we're using that web application firewall to be able to do that. From a zero trust perspective, this is where we're applying that web application firewall at each edge with specific rule sets. So in this design, we're simply showing it between the CDN layer and the load balancer. In practice, really what you would do is you would apply the web application firewall at the CDN layer as well as at the load balancer layer. And what you want to do is you want to create rules that are specific to the traffic that is expected to be traversing that portion of the network. So in the CDN point, this is the sort of unwashed masses of the internet, right? So we want to be the most restrictive on that edge and assume that all traffic has sort of malicious intent. Between the next two steps, we have a greater sense of what the traffic should look like. So our rule set can be much more granular in terms of the protocol and the communication channel that we expect. But from a zero trust mindset, again, we don't want to simply assume that because it's communicating to these 2 points that it's secure. So again, we apply rule sets that evaluate the risk based on anomaly detection or other capabilities. And so that's where we're going to get more in depth into monitoring and actually looking at the data that's traversing it.
So from an IPv6 perspective, so as Brad mentioned, like if you have a user on the internet, it can use Amazon Route 53 to create DNS records specifically for IPv6. So that would be like a CORD A record that you can then point to either to a CloudFront distribution, and CloudFront supports IPv6 on the front end connection, meaning from the viewer to the CloudFront. So in that case, you can use IPv6 there. And as you know, AWS WAF integrates with CloudFront as well. So you can use WAF and CloudFront together in conjunction, where you can do filtering on the WAF and create this allow or deny list for IPv6 based addresses.
So let's move around on the grid. At this point, we're talking to, in this case, an endpoint, and that endpoint is going to be talking to, in this case, a network load balancer to a microservice that exists as part of the three-tier application. So again, from a TIC perspective, we would address this as meeting a WebPEP security capability. We can use this as an authenticated proxy point. This allows us to also speak to a number of different PEPs on network segmentation as well as access control, because again, this is not just a network boundary. The endpoints allow us to specify resource policies on them as well, and we can also use those resource policies in conjunction with services that support their own resource policies to say things like, if this was talking to an S3 bucket and it was a service endpoint, I will only listen to this service endpoint, and the bucket will only communicate to that particular service endpoint. In this case, we're using both a network layer construct as well as an identity construct to push through to say that only this particular role or capability is allowed to talk to this particular application. From a zero trust perspective, this is still an area where we want to have a tight edge perimeter. So we want to make sure that we're limiting access to this particular microsegment. So rather than allowing everything in the three-tier architecture to communicate with it, we're applying the endpoint in a particular subnet, and that subnet is where we expect the communication to traverse to that particular function. And then again, we can constrain more tightly at this point what we expect that traffic to be, the size, volume, and velocity of that traffic, so that we can do further anomaly detection and not rely solely just on, it's in the same flat network space. We're carving it into a separate area, and then we're using the identity-centric controls of role-based access to allow us to communicate with that particular resource. Again, from a DoD perspective, this would be where we're defining our micro perimeter. So we're trying to define the edge of this sub-application as one of those micro perimeters.
So from an IPv6 perspective, we recently launched IPv6 support for private link. And what that means is that on your service provider side, you can have your network load balancer that runs in a dual stack mode. And the targets for the network load balancer can either be an IPv4 or IPv6, depending upon your use case. And you can use that to expose that service for all of your consumers. Either those consumers could be in the same account, different VPCs, and you can expose that IPv6 service for all of your consumers. And the way this works is today is that you create this dual stack network load balancer on the service provider side and expose that on the consumer side, where the consumer can then have IPv6 addresses for the VPC endpoint elastic network interfaces to enable that IPv6 connectivity for your users.
So on the lower portion of the screen, we have a number of services that would be used for meeting, for example, universal security capabilities. So we would use services like Systems Manager to help us address things like inventory, being able to describe what is actually on the EC2 instances. That allows us to get information about what version of a particular library or package is installed, also to help us better understand what the fleet looks like. We also would use services like AWS Backup to meet requirements for backup and resiliency, so we can use backup to address that capability. Generally, when we use backup in these types of scenarios, we tell customers that we want to back up that environment to a separate enclave, a separate account, separate vault, separate key material. And the idea is that allows us to not simply rely on the fact that we have a backup that's in a separate escrowed environment that requires separate authorizations to use access to get that backup back. This is also something that's commonly used as part of a ransomware mitigation strategy to make sure that we're backing up to a separate enclave. From a zero trust perspective, this is where we would get into device dynamic posture assessment. So using, again, tooling like Sessions Manager or the run command, we can go and get active running processes across the fleet. So we can use the run command to issue process lists in both PowerShell as well as Linux Bash environments, get things like netstats so I can see what actual listening ports processes are currently enabled on the fleet. And then also the ability to address continuous integration or continuous deployment requirements around automated configuration management, things like DevSecOps pipelines. And that is in both using tooling like Systems Manager, but also tools like AWS Config to get posture assessments of the environment and making sure that a known expected state of the environment is currently the way that the fleet is working. So in plain English, I expect all of the fleet right now to have encrypted EBS volumes. We can use config to validate that, and when non-compliance occurs, we can use automation to remediate that non-compliance. From a security aggregation capability, from a threat detection capability, this is where we would use tooling like GuardDuty. GuardDuty allows us to aggregate that threat intelligence up to a singular parent account inside of the organization. And then if we wanted to view that holistically across all of the different AWS security services, we would leverage a tool like Security Hub, which allows us to aggregate data from not only GuardDuty, but a number of AWS security services, Detective, among others. And we can have that SOC analyst or that security analyst look at the threat intelligence from not just one account, but from the entire agency or the entire organization. This has proven really important for customers that are really trying to up their risk management, their threat management game, because it allows you to see when an actor is moving laterally across multiple accounts at the same time.
So from an IPv6 perspective, none of the services that are shown here support IPv6 today, but we are aware of your needs and we are taking that as a feature request.
And then sort of in the middle, this is where we would use something like a network firewall. So again, this from a WebPep capability allows us to perform malicious content filtering as well as access control. If you didn't know, network firewall allows us to do stateful and stateless packet filtering, and it also allows us to use Suricata-based rules. So if you're a user today of a tool like Snort, it'll feel very comfortable in terms of how you craft and deliver the rule sets. This can be used in both a decoupled or decentralized and a centralized model. So in TIC, we see customers use this as part of a central inspection point. This is very analogous to folks that are more accustomed to a TIC2 environment that used Einstein devices, where effectively traffic went through a single inspection point. You can do something similar with a transit gateway in a central model using the network firewall. But again, this is really meant to address sort of those network-centric controls. From a zero trust perspective, this is where we're going to do more layer 3 access control. So we can do this both on an individual application basis, in this case a single 3-tier application, but we could also use tooling like RAM to be able to deploy policies as well as firewall manager to be able to centrally monitor and deploy policies to the network firewall, as well as performing DNS filtering. So if we wanted to do DNS ingress or egress, allow or deny listing, we could do it centrally with the network firewall tool.
So from an IPv6 perspective, AWS Network Firewall does not support IPv6 today. So if you're looking to use IPv6 with Network Firewall, either in a centralized or a decentralized manner, we have seen customers go with the route of NAT66, although some of them have been hesitant to go that route. So once we have support for network, once we have IPv6 support for Network Firewall, that would be something that would simplify that.
So on the first example, what we wanted to cover first was sort of where we overlapped. So you saw there was a lot of overlap initially between all three of us at the edge. So coming in from Route 53 to sort of the first few hops. At that point, it starts to diverge a little bit. Some services have full support across all three. Some have a mixed environment. If you need a situation where, for example, in TIC, you wanted to do break and inspect, that's not something natively that we support as a service today. So this is where we would introduce partner solutions that can help you meet the requirements for break and inspect. From a zero trust perspective, if we wanted to do dynamic posture awareness, again, this is something where we would leverage a partner solution that could be deployed on a per instance level to help get better telemetry or better information about susceptibility to AV issues or malware issues on the individual hosts. And then from a software-defined networking perspective, again, when we start to move in and out of different VPCs, if you're using overlay technologies from a vendor-supplied solution, this is where it can get a little bit tricky. So that's, again, where we rely heavily on some of the partner solutions to help if you're going to be doing heavily overlaid solutions.
So from an IPv6 perspective, as mentioned about network firewall does not support IPv6 today. Also with respect to guard duty also, it does not support IPv6 addresses either in your trusted list or your threat list today.
Great. Okay. So let's move on to a different scenario. So this is something that we see more commonly with our federal customers today. So they're moving to more containerized, more abstracted services. So in this environment, it's going to look a little bit familiar to the previous environment. We've got sort of a web-based application that's coming in through a DNS entry in Route 53. But instead of going to a back-end fleet of EC2 instances, this time we're going to be using a mix of serverless Lambda functions as well as containerized applications that are going to be running in Fargate through ECS or EKS. We're also going to be communicating across accounts through inter-service communication via Lambda function with cross-account role access. So again, as before, we sort of annotated where there's TIC3 zero trust and IPv6 overlays. So we wanted to kind of walk around the board and explain how this kind of comes together. The biggest difference at the outset edge is that we also included Lambda at edge at the CloudFront location. So this allows us to start pushing, again, more of that server logic out to the farthest edge rather than trying to get it back into the inner perimeter. So from a zero trust perspective, again, I don't need to get that connectivity all the way back into my cloud environment. I can try and push it all the way out to the edge where possible. So on the lowest portion first, let's talk about role-based access. So from a TIC perspective in this design, this again goes into the WebPEP security capabilities, specifically speaking to access control. So we're using cross-account role access in this environment for Lambda communication to a separate function and a separate account. When we do this, we want to ensure that, A, there's a trust policy that exists between that role and the different account, but also trying to get to concepts like least privilege. So we want to make sure that that role that's communicating with that function has the least amount of permission to do exactly what its function is supposed to do and absolutely nothing more. For some customers, that's proven challenging because as they develop with AWS, the developers may not be accustomed to all the different verbs that are possible within the API language. So we've tried to make that easier through tooling like the Access Analyzer and Access Advisor tool. So in this environment, we're using Access Analyzer to help us address the TIC3 and PEP zero trust PEP requirements for least privilege and attribute-based access control, or what's called ABAC, or role-based access control, or RBAC. And so we use the Access Analyzer tool to basically get a replay of what that function has actually done as opposed to what we think it does. And then we can actually output directly from that tool a policy that matches exactly what the function does down to the verb. Now, when we sit down with customers that are looking to be more zero trust focused on that, we today don't support the ability to do in-depth conditionals on that evaluation and Access Analyzer. So it is giving you to the verb on the individual API calls, but it's not context aware. And what that means in plain English is it doesn't understand that I want to ensure that this role can only be called from this particular VPC, or that it comes from this source IP address range, or another attribute that may be present inside of the environment. So that's where you still need to do a little bit of lookup on your part in order to get to that more ABAC type model. But if that's something that's challenging to your team, that's again where your solutions architect team or specialist community can come and help you understand how to interpret that and how to get to more fine-grained policies.
From an IPv6 perspective, you can have IPv6 addresses that you can either allow or deny for in your IAM policies for your identity and access management purposes.
So the idea in that case is, again, we can use that constraint for IPv6 access inside of the policy and, again, make sure that we're staying in an IPv6 only space. Going up, in this case, a little bit different now. So instead of using EC2, we've moved to a containerized application. So we're going to Fargate. So in this case, we're going to start talking about network policy enforcement points, or network PEPs. And so this starts to get to micro-segmentation within TIC3. So we want to use this to send requests to more abstracted, containerized services that are purpose-built, singular-focused for what specifically they should be doing, rather than monolithic, large-scale EC2 instances. This allows for a significant attack surface reduction, because rather than relying on an entire operating system with all the associated libraries that are required to run it, we can create much more tightly scoped containers with much more tightly scoped policies around the way that the application is controlled. Also, from a security patch management capability, it's really easy to deploy a new fleet of containers and blue-green deployments, where in an EC2 environment, if you're using a CI workflow, it takes a little bit more time usually to spin up the fleet, patch and configure the fleet, and then configure for a load balancer kickover. So really, from a TIC3 perspective, this also speaks to application containment, making sure that, again, the application function does exactly what it's supposed to do and nothing else. From a zero trust perspective, this is where we start to get into functional segmentation. So we want to make sure that the purpose-built container does exactly what it's supposed to do and nothing else. So we're not running an Nginx server alongside a MySQL database on the same EC2 instance. We want it to be as loosely coupled as possible. The also advantage that's really important to take away from that is that allows your developers to be hyper-focused on what they're actually developing, rather than having to try and figure out, if I deploy this patch, will it break the entire system? They can focus just on that individual container, because it's well understood, well known what that individual function does. The other benefit from a containerization approach is lack of persistence. So when a container usually operates, usually the container function will execute and then subside. So from an attack surface perspective, unlike an EC2 instance where the operating system continually continues to work, a containerized function traditionally will terminate at the end of the successful completion of the function call. So in plain English, an attacker can't get persistence on a container once the container function has actually completed its job. Also, that speaks to surface reduction. So for anyone that's ever had to deal with the checkbox of compliance, Nmap scans, where we have all these operating systems that have weird ports and processes open for weird tools that have to be run to scan the environment. This is a huge surface reduction, because again, these are purpose-built utilities, and they can much more tightly couple with their parent-child relationship. So again, in plain English, if I have a web server container and a database container, I can have a strong connection between just those two, which again allows us to not expose anything else to the environment, because we expect those two containers to communicate with each other and nothing else.
So from an IPv6 standpoint, all these three container services, which is Amazon EKS, Amazon ECS, and AWS Fargate, support IPv6. So let's take an example of Amazon ECS. So with Amazon ECS, IPv6 supported for host networking mode as well as AWS VPC mode. And you can run your containers either on EC2 or on Fargate and enable IPv6 connectivity for your containers as well. And to do that, you have to make sure that you are using the latest VPC CNI plugins as well as the latest platform versions that are available, to make sure that you are getting the IPv6 support for your tasks that you are running. From an Amazon EKS perspective, a few months ago, we launched support for IPv6 for pod-to-pod connection as well as pods and services for IPv6. And you can have IPv6 support for your EKS mode using at the cluster creation, using either, primarily using through IP prefix assignment mode, and have IPv6 addresses assigned to your containers. And all of these three containers you can use to front-end it with application or network load balancer and have end-to-end IPv6 connectivity.
So you can see story gets a little bit easier from IPv6 in this case as well. So going into the middle section now, so now we've got our edge connection, in this case going to an API gateway endpoint instead of to just a load balancer. So in this environment, from a zero trust TIC3 environment, this starts to allow us to address things like the intrusion detection PEP. This allows us to go and actually look at not only what's taking place on the function, but to actually do a deeper dive on the function as it executes. And for that, we would use tooling like AWS X-Ray to be able to actually understand how the function is executing executing and make sure that it's a value, that it's actually running in a way that we feel confident that is expected. That also allows us to have a higher degree of flexibility in debugging the environment because some of these Lambda functions that I've seen developed can have a huge number of libraries associated with them, so it's sort of a question of what does this thing do? When we use services like X-Ray, it gives us a better sense of what's actually taking place under the hood, but it also helps threat hunters to understand if there's an attack surface that we need to address. From a zero trust perspective, there's a strong authentication feedback loop that takes place here, so we can tie identity and network-aware controls in the API gateway communication to the Lambda function, as well as to Lambda communication, so that it's not just that we're in the same account boundary or that we're in the same VPC. We're using that role-based access that we highlighted earlier to make sure that this specific function can only talk to this specific function, and we can increase that by using attribute-based access. So things like tags on those functions that indicate the difference between a development environment and a prod environment, data classification, high, low, or other attributes that are present in the environment. Again, from a DoD perspective, this allows us to get closer to those requirements for microperimeters. We're very, decoupling those different functions. And so in this environment, sort of slightly off to the right, you can see that we're talking to a separate API gateway. The idea there is that from a zero trust perspective, we can, rather than have the individual functions freely be able to communicate with all functions, if we want to talk to a sensitive operation, we can front that with an API gateway, which then allows us to apply yet another filter layer like WAF that we saw in the previous environment, which, because we know exactly what that flow is tightly between those two functions, we can craft exceedingly granular policies for that web application firewall, because it's a small jump in the environment. So we don't implicitly trust that just because you're in the same account boundary or that you're in the same environment that these Lambda functions must be friendly to each other. We treat them inherently as hostile, and we use that API gateway as a buffer to ensure that only expected size ranges and only expected inputs and outputs can traverse that boundary. From another example there, that also allows us to communicate more safely with compute services or database services like Dynamo, again, allowing us to greatly control the ingress and egress of the traffic there.
So from an IPv6 perspective, we recently launched IPv6 support to invoke Lambda functions for the inbound connections over IPv6. So you now have an API called lambda.region.api.aws where you can use to invoke IPv6 for the inbound connectivity to Lambda.
Sort of moving a little bit lower in the stack, so now we've got that sub Lambda function talking to the API gateway, which is talking to another Lambda function. That was that workflow that we were talking about earlier. From a TIC perspective, this allows us to start to address regional resilience capabilities or regional delivery capabilities. So when we talk to that sub function, the microservice 3 that's listed on the far right-hand side of the corner, that allows us to do perhaps regionally context-aware delivery of a payload or of an artifact within that application or application logic. So in plain English, I have a function that needs to give citizenry information to a particular geography, but we're bound by law based on things like GDPR or other compliance requirements to keep that data in that nation state's borders. We can use that microservice to microservice call to make sure that we're still in compliance by making that call to that microservice that exists in that region, rather than deploying it holistically in one singular account boundary. The other benefit to that is that we're deploying it in the same methodology as the other Lambda functions, which again is serverless by design. But again, because we're using a separate API gateway in this case, that allows us to apply again that perimeter protection via web application firewall to say, we expect traffic to be moving in this direction from this size, this velocity, this rate limit, and again, allowing us to more tightly constrain operations between those two functions. And then obviously between the API gateway and the Lambda function itself, we have the same constraints that we saw earlier. From an IPv6 capability, there today isn't any changes on this one. So where did we overlap on this one? So again, you can see that in the containerized environment, the overlap between Zero Trust, TIC, and IPv6 was really strong in the containerized space. So EKS, Fargate, really, really good story there from the outer edge, same as the 3-tier architecture. Bringing you all the way into that edge is pretty seamless. And again, that's where we could use tooling like an ALB to go directly from that CDN layer to an ALB to a containerized fleet. If you didn't want to use an API model or an API gateway model, this is something, again, where your solutions architect team or specialist community can really help you meet that OMB requirement for IPv6 end-to-end in a containerized environment. And again, as I wanted to sort of point out, we're not encapsulating every single PEP and every single one of these controls as well as every single Zero Trust concept. We just want to give you sort of a taste of what it looks like to meet those. From a challenge in this architecture that we've seen with customers from a TIC perspective, if you deploy this type of model in a centralized hub and spoke, and what I mean by that is you're using that TIC2 mindset of we have a central transit gateway that we're doing inspection both inbound and outbound of the environment. This has proven a little bit tricky for customers that are using partner solutions. So if you're using a partner-managed firewall or load balancer solution, distributing that traffic at scale to huge amounts of containerized applications has proven to be a little bit tricky. We have a couple good workarounds for that, but that's something where we would need to sit down and talk about your individual applications and help you understand whether or not it's appropriate to do centralized inspection. From a Zero Trust perspective, again, defining that software network perimeter around each one of those spokes, that's something if you're using a partner-based solution, we can help you understand what the sort of limitations and capabilities there are. From a container authentication capability, so making sure that if you're passing identity between things like the ALB, that you're using services like Cognito or SAML provider to do that person-entity validation of the caller. And then from an EC2 roles perspective, making sure that we're not allowing human access to those resources. So in a containerized environment, that's sort of a no-brainer. These are containerized. You shouldn't be providing shell access to containers. But that's a mind change for a lot of folks, right? So really helping them understand that paradigm shift of individual roles on the containers and not allowing persistence and remote connectivity via tools like Systems Manager has proven a little bit tricky for some customers. And then finally, device dynamic posture awareness. So if you need to do a posture assessment of the container itself, this is where traditionally we would work with partner-based solutions to give you a better holistic at-scale analysis of the containers across multiple accounts in multiple regions.
So from an IPv6 perspective, as we saw that you can have end-to-end IPv6 connectivity with your load balancer application and network load balancer and have container services running behind it. There are some challenges with IPv6 as well, with the containerized workloads as well, such as like the Amazon EKS control plane and the worker nodes today only support IPv4 for the connectivity, and API gateway does not support IPv6 today.
Great. So moving on to another scenario, virtual desktop or remote desktop environments. So this was, I'm sure, near and dear to everyone's heart over the last 2 years. There was the interim guidance on telework. So what we wanted to do is sort of walk through what does it look like to support a remote desktop or VDI solution inside of the environment. In this case, we're using a mix of Amazon Workspaces, AppStream, and an Amazon capability called Nice DCV. So what we want to do is sort of walk through how does this work from, again, a TIC3 Zero Trust and IPv6 capability. So the first area that we wanted to focus on, if we're using a tool like Workspaces, this allows us to get into the TIC3 universal security capabilities for strong authentication, because when we use Workspaces to connect to that remote desktop, that allows us to centrally integrate with your existing identity solution. So if you're using a third-party identity store or Active Directory environment, something that's integrated with Radius for CAC PIV authentication or integration. We can do that now natively with Workspaces, so you can pass through your CAC card into the Workspaces service. If we're using token-based authentication, again, it integrates with the existing tooling that you have, and that allows us to, again, meet that strong authentication requirement, but also from a Zero Trust perspective, that allows us to get to that MFA, again, CAC PIV requirement. For the DoD, it gets us closer to the ICAM requirements for identity credential access management, and that ties really tightly into your existing human resources onboarding and offboarding program, so that when folks come on and out of the agency, their access is terminated tightly with those existing human resources processes.
So from an IPv6 perspective, you have to check on these clients whether the Active Corporate Directory or the Radius supports IPv6 or not.
So the next portion would be, we're not going to use workspaces, so we're going to use a service like AppStream. So in this case, this allows us to speak to the enterprise PEP for remote desktop access. So we're going to use AppStream to push individual applications rather than a full-blown desktop environment to our remote users. This has the benefit of lower patch issues, so I'm not running a full-blown desktop environment anymore. I'm simply serving an individual application or an individual portal to an application. So some customers will use AppStream to serve a browser, which then has direct access to, in our case, a VPC with a secure application. So we're using this basically to get pixels of an internal app rather than allowing the data to actually go to the end user's mobile device. So in both the workspaces environment as well as the AppStream environment, what's moving over the wire is pixels. The data from the environment is never actually going to the end user's device. It's strictly the sort of screen recording of what's going on. From a zero trust perspective, this allows us to meet network segmentation controls because, again, we can start to serve content inside of secure enclave borders and allow just-in-time access. So again, in AppStream, it's based on fleets that can be dynamically added or removed from the fleet, whereas in workspaces, it's based on usually a more one-to-one mapping of an individual user to an individual workspace, at least classically. AppStream is more focused on simply connecting to an endpoint and then providing that resource to the user. From an IPv6 capability, today neither of these support direct v6 access. So what we've done with customers that require that is using a tool called NiceDCV. NiceDCV has its roots in the high-performance compute community. So it was originally used to allow folks to do offline or remote rendering of complex geometries or models. So the performance is fantastic. You get as close to near real time as possible interactions with complicated three-dimensional objects. In our case, we're just using it for lowly VDI operations. But from an enterprise perspective within TIC3, again, this allows us to meet those remote desktop access requirements. From a zero trust perspective, just like before, network segmentation, just-in-time access, secure communication, because we're using the secure channel to the NiceDCV server. And as we found out,
NiceDCV supports IPv6, so what you can do is you can create an EC2 instance where you are running the NiceDCV server and then connect it from the client, and you can get IPv6 connectivity to the NiceDCV server. This is possible because you're running that on an EC2 instance and you're able to have IPv6 connectivity there. And from there onwards, you can then have connectivity either to other VPCs over peering or transit gateway.
So that allows us to get that sort of v6 end-to-end communication with theoretically a v6 only application that's being hosted inside of our secure enclave where our workspace is or where our AppStream environment is. So theoretically we could go v6 all the way to that. Again, the value here from both a TIC and zero trust perspective is really that this entire environment is self-contained. So you can imagine a situation where, let's say, we have sensitive investigation information and we don't allow it to, escape the boundary. We can use this design to have access to an internal set of applications like a SharePoint server or a web portal that is never exposed to the public internet. Instead, it requires access through one of these remote VDI technologies so that we're seeing strictly what we're allowed to see, and then we can have the same controls inside that perimeter as you would have inside of a traditional environment. So from an overlap perspective, a little bit less on this example between all three of us. The tightest overlap was when we were using NiceDCV for v6, TIC3, and zero trust. From a TIC perspective, the challenges that we see for customers is the egress content filtering. So you can use tooling like Network Firewall, but in practice, what we see customers want to do is more filtering based on things like web content or making sure that certain categories of resources can't be communicated with. This is where you use the traditional inline filtering solutions that are classically provided by partners. You're probably using them in your environments today. The other is obviously AWS doesn't have any host antivirus malware solution. So the same tooling that you would use in your corporate environment almost always is extended to the workspace environment as part of the compliance process. So the same agent that you're using for AV malware scanning would be extended to this. And then from an AppStream perspective, again, that would carry over as well as sort of the NICE DCV. From a zero trust perspective, the challenge that we see is the dynamic posture awareness. This is most true for the end user device, so the tablet, Chromebook, whatever it is, as well as the internal device posture of, for example, the workspace environment. Traditionally, this has always relied on the existing partner solution that the agency or environment has been leveraging. So again, if you have a tool that you're using, almost always it's going to be the same tool that you're going to continue to use inside of this environment. And just as before, because we're traversing a number of different networking environments, it can get a little bit messy on the software-defined network perimeters.
So from a connectivity perspective, the remote users that you have, they do not have an option to connect two workspaces over IPv6. So the client to the workspaces connectivity is still IPv4 today. In addition to that, the streaming gateways as well as the PCOIP servers also do not support IPv6 today. You have to have the IPv4 connectivity for that today.
But once you're inside of the environment, that's where if you're allowed to do dual stack, you can kind of get away with it.
Exactly.
Okay, the last one that we wanted to run through was hybrid and edge computing environment. So in this environment, we wanted to focus on something that we're seeing a lot with customers around the globe, which is moving to more hybrid solutions using services like AWS Outposts, the Snow family of resources, as well as peering directly with AWS over secure communication channels like a Direct Connect or VPN. So we wanted to walk through a couple areas where there's overlap between TIC, Zero Trust, and V6 on this. So we'll start with the first edge. And from a TIC perspective, this allows us to start speaking to the enterprise PEP requirement, again, on the far right for that VPN connection, allowing us to have a direct VPN access to, in this case, a secure enclave or secure web application. So we've traversed our corporate network over a traditional VPN tunnel. From the left-hand side of the screen, or I guess your right side of the screen, this is where we would use services like Direct Connect. This allows us to communicate over V6, but it also allows us to have strong MACsec support. So we're having high assurance of end-to-end encryption between your corporate facility and the peering point. So it's MACsec encrypted for a number of peering points that support that capability now. And then obviously from a zero trust perspective, the VPN allows us to meet the requirements for strong identity and authentication requirements. So it ties into the existing identity or ICAM solution that you're using for your existing VPN solutions today. So that's both a network-aware context as well as an identity-aware context.
So from an IPv6 perspective, Direct Connect supports IPv6 on all three virtual interfaces, which is public, transit, and private virtual interfaces. So for example, if you have a service that supports IPv6, and we can take that example of S3, you can have all IPv6 connectivity from your on-premises environment to S3 over IPv6. And when you configure the BGP peering session for the IPv6, you are going to receive all IPv6 routes from AWS back to your on-premises environment as well. And depending upon whether the service supports IPv6 or not, you will have the IPv6 connectivity over public virtual interfaces as well. And same applies for transit as well as private virtual interfaces. In case of site-to-site VPN connection, the key thing to remember from an IPv6 perspective is that you need to terminate the site-to-site VPN connection on the transit gateway itself. If you terminate the VPN connection on the virtual private gateways, we do not support IPv6 there today. So in addition to that, you can't have both IPv4 and IPv6 within the same VPN connection that you establish from your on-premises to AWS. You need to have two separate VPN connections, one to carry your IPv4 traffic and one to carry your IPv6 traffic. And also on the customer, on your on-premises environment, you will have a customer gateway that will be acting as your customer gateway device. So when you configure the customer gateway on the AWS side, in the AWS console, it still supports IPv4. So the way IPv6 connectivity works from a VPN standpoint is that the outer tunnel IP addresses will still be IPv4, and we will be carrying an IPv6 traffic within that tunnel to have that IPv6 connectivity to AWS.
Cool. Moving inside, so again, when we take that direct connect or that peered connection, we're going to a transit gateway inside of this environment. So this allows us to meet networking PEP requirements for segmentation. When we get into the actual application itself, obviously we start to speak to a number of PEP's requirements for elastic expansion, so we can dynamically scale the resource based on conditions like load or other indicators. Also regional delivery, so we can take that transit gateway and we can communicate with different regions in order to meet durability or resilience requirements for TIC as well as agencies, individual requirements. From a zero trust perspective, again, this gets into the same context as before. This is network segmentation, micro-segmentation. We can use that hub and spoke model from the direct connect and from your corporate data center or peering point to allow us to then splinter out to a number of different applications and put context in both an identity-aware constraint as well as a network-aware constraint from the transit gateway to the application, carrying through whatever authentication mechanism that you're using.
So from the networking standpoint here, the transit gateway supports IPv6, so you'll have VPC attachments that you can create to the transit gateway and have IPv6 connectivity between the two VPCs that are connected to the transit gateway. In addition to that, as I just mentioned, that you can have IPv6 connectivity with direct connect on the transit virtual interfaces as well. So you can have IPv6 connectivity with direct connect and transit gateway and integrate that and have IPv6 connectivity from AWS and on-prem and vice versa. In addition to that, while customers and the industry is moving towards IPv6 if you have a use case where you still have IPv4 endpoints either on your on-premises environment or on the internet, you can now have the ability to initiate outbound connections from IPv6 only subnets through DNS64, NAT64 to go talk to your IPv4 endpoints, right? Those IPv4 endpoints could still either be on the internet or could be in another peered VPC or within the same VPC as well in a different subnet and have that connectivity over IPv6 there.
Cool. Then when we get into the lower portion, this is where we're using an outpost in this environment. So we're using an outpost extension to, in this case, an individual region. We also have a Snowball Edge device. So from a TIC perspective, this allows us to, again, deploy based on resilience PEP. So we want to have resources not only in the cloud, but we need them in our on-prem data center or facility. This also allows us to meet data sovereignty issues. So if we want to make sure that the data stays in CONUS, or again, we're partnering with another nation state for identity or passport control or something else, and they have a requirement for identity remaining in country, we can use the outpost or region service delivery to meet that requirement. Obviously, again, this allows us to have a strong network segmentation, so we're peering it directly with our existing corporate data center alongside them, but also having that service link channel between the outpost environment and the designated outpost region. This also allows us to do tighter application containment as well as secure administration because everything that's stored in the environment allows us to control it via API rather than having to go hands-on metal and actually interact with it. So it's the same API environment that you use to create and destroy resources, which ties into the same identity and access controls that exist in region, but in this environment it's using outposts. Likewise, we can use the Snowball Edge device to store the content locally as well. From a zero trust perspective, this again allows us to do local data processing. If we're using Outposts, that also allows us to perform a destructive operation using the encryption key. So each of the outposts comes with an encryption key that if you're going to terminate access to the rack, you can actually tighten a screw, which will break the physical key and allow you to safely decontaminate the rack. And it also speaks to concerns around data loss prevention. Today, there is no Outpost native support for IPv6, and the same is true for the Snowball Edge devices. So from an overlap perspective, you can see that we have a lot of synergy on the VPN direct connect side where we're able to get into the AWS environment to a transit gateway and to sort of hub and spoke from there in v6 only compliant modes, as well as that allows us to do good, strong network segmentation for TIC3 requirements and zero trust requirements. From a TIC perspective, the challenge here, oddly, is resilience. And the reason I say resilience is when you deploy an outpost, it's a real physical server in your real physical data center. So now the onus is on you to actually make sure that if you are using this as a single point of analysis or you're not distributing that workload back to the peered region, you need to make sure that you have enough outpost racks to be able to support something like a single bus bar going offline, knocking out power to that enclosure. From a zero trust perspective, again, dynamic posture awareness of the fleet and resources, same as before. We use partner-based solutions. For backups, when you do a snapshot on an outpost, by default, the snapshot is stored in S3 in the peered region. If that's not acceptable, you can use part of the outpost rack as an S3 storage space, or if you have an S3 dedicated rack, you can designate that as the snapshot location. So it's just something that you actually need to know and be aware of and configure. And then same as before, because we're using a software-defined network for both a physical and virtual environment, we need to make sure that we're tightly understanding those pathways for application perimeters.
So from an IPv6 perspective, as Brad mentioned, Outpost today does not support IPv6.
Cool. So what we wanted to take away from this talk is that mission critical systems are how governments get work done. So oftentimes we see customers building out these legacy solutions, and it's making it really hard to serve the public and citizenry. It's also really hard to get data when you need it to, and to make sure that your information is secure and that you're able to properly secure and make sure that your resources are compliant. The cloud can help you with all this, so we can help you innovate more quickly, make decisions better, build better public trust. A good example of that was our partnership on the COVID test kit delivery. That rollout went exceedingly well, and I think that was a great example of what public-private looks like. Also from a mission-critical system, they should be able to instantly meet demand. They should have cost models based on actual usage, and they should be easy to update. This is a requirement not only for just general day-to-day use, but this ties really closely into concepts around TIC3, Zero Trust, and from a budgeting and ease of use, also IPv6. We also want to make sure to call out that state and local governments are using the cloud to understand data in new ways, to create better user experiences for their citizenry, and to build more efficient and resilient systems. And if that's something that sounds like it's interesting to you, it's easy to get started. We can help you. You have a solutions architect, whether or not you know it or not, that can sit down with you and help you plot out your journey to the cloud. If that sounds like something you're interested in, or you want to develop your own skills, there's a number of free digital courses that are available that can help you level up your capabilities on the AWS, as well as if you want to get certifications. There's a number of certifications not only for AWS, but also specialty areas like networking, security, as well as concepts like big data and others. So if these are areas where you want to get deeper into the weeds, those certifications are a great way to go. We're at time, so I want to thank everyone for coming. We'll hang out and take any questions that you have, but otherwise, thanks very much, and we hope you have a great summit.